Building retuning training was conducted by Ron Underhill and Gupong Liu, scientists at the Pacific Northwest National Laboratory. Classroom and on-site training for Maryland State Agency facility managers was conducted at Towson University in Towson, Maryland on June 17th through the 19th, 2014. This segment of training covers building walk-down.
Purpose of a building walk-down, obviously, is to get to know your building better. It's been emphasized already. We don't want to armchair quarterback our building, whether it's sitting in front of the BAS, whether it's sitting in front of a set of prints. Sooner or later, if the data is telling me I got opportunities or I got problems, I need to walk down the building. Main reason is impressions, overall building condition, design, HVAC systems, how they're operating. Is there things that could be improved in any or all those areas? So some of these things we're going to fly through. I don't want to belabor some of these areas. We're assuming that most people that are operating your building, familiar with your building, already have electrical and mechanical prints. Hopefully they've already looked at them. Hopefully they understand them. Some of the things that I highlight or want to emphasize when you're looking at mechanical prints, what type of HVAC system designs do I have? Are they constant volume? Do I have VAV systems? How many zones do I have? How many perimeter zones? How many terminal boxes? You know, is it a good design? Am I zoned properly? Do I have systems that are feeding an HVAC system that's feeding both perimeter and interior zones, which becomes problematic? Do I have an HVAC system that's serving a corner office and then a bunch of other offices? Corner offices are problematic because of the exposure, generally to at least 2 exposures. There may be other things that you identify on the mechanical prints that you weren't aware of yourself that the engineer did. If it's an older building, a lot of times you find opportunities. And as I think of them, I'll throw them out. Just real quickly, legacy systems. I'll just talk about legacy systems. What do you mean when you say legacy systems? A lot of public buildings, especially in the GSA, DOE, DOD portfolio, maybe some of the, I doubt college campuses, but you never know. State buildings, you never know. Smoking rooms, big thing, you know. And I know we're in Maryland and tobacco's still grown here, but I think most public buildings have outlawed smoking in public buildings. They have or had rooms where you could go and smoke. And they've completely outlawed it to the point where the exhaust fans that serve those spaces serve no function. So is the exhaust fan still running? It's now a legacy system. Was it shut down? If it was shut down, should it be removed and capped on the roof? Does it have an isolation damper? Is it an infiltration point for hot, humid air or cold air? That's one example of a legacy system. There's a lot of, I just demoed out a boiler. I got a stack going up through the roof. I got steam lines going here and there. Did I demo them all out? It's a penetration through my envelope, the stack. Did I get rid of it and seal it off? Those are what we're talking about when we're looking at mechanical prints, where there's opportunities to find more opportunities. Electrical prints, anything greater than 3.7 kW, 5 horsepower, that might be an opportunity to identify on the electrical print. There's a lot of things on electrical prints. Ceiling radiant heaters. I can't believe how many buildings put them in. They're legacy, but some of those things are big energy hogs. And they're out of sight, out of mind, until you walk around with an infrared camera and you go, wow, look at that bright red. Because you don't know they're there. Heat trace. Heat trace. Heat trace on gutters. Heat trace for cooling tower, domestic hot water lines. Those, should I turn them off? No, you got to protect what the heat trace was installed for. But are they operating correctly? Do I know that they're there? So when we're looking at that previous chart about my baseline load, and we're saying, you know, there should be about a 30 to 50% difference between unoccupied and occupied. Where's my baseline loads? Well, look at your electrical prints and start getting an idea of everything that might potentially be out there, but I'm not even aware of. If I'm looking strictly at the BAS, I'm going to miss stuff. Because not everything is on the BAS. Lights is another one. So we want to walk the outside of the building. The only reason why we want to walk the outside of the building is we want to understand, are there challenges with this building, the way it's oriented, solar heat gain, how many windows, what's the window wall ratio. So it's got a lot of glass, beautiful building, but it's got a lot of glass. So now we know it's challenged potentially in the wintertime. Cold winds blowing, it's losing a lot of heat. Summertime, it's gaining a lot of heat. Orientation of the building. Windows, somebody said, are they operable? Yes, they are. Are they open? So should windows be open if they're operable in our buildings? I'll just throw that out as a discussion point. No.
Depends on which office.
And you know, hey, people are people, and when we give someone the ability to operate something, whether it's a light switch, a window, and a year ago we were in Pennsylvania, and we came back out and we did our small building retuning, and it was June, and it was extremely hot and humid. They had an elementary school, and they said, we got problems. Well, yeah, you walk up to the building, and all the windows were wide open, and you walked through the front door, and it hit you. I mean, when I say it, meaning the humidity in that building just hit you. And then you realize there's little kids, it's an elementary school, and they're trying to teach. And the teachers are doing the best they can, and I didn't blame any one of them for going to the windows and opening them up. At least they got a breeze. And so why was that going on? Well, they were trying to save energy. How were they saving energy? They thought they were saving energy. The person responsible for operating things decided that instead of dehumidifying down to 50% or 55%, he'd save more energy by letting the humidity level get up to about 65%. And that's borderline unbearable if you look at the ASHRAE chart. And in fact, in some cases it was even higher because it was, sensors and, like I said earlier, calibration and so on and so forth. So we said, hey, get those humidity set points back down. Start dehumidifying the space, because what happens is the windows go open, and I can guarantee you they stayed open all night, all weekend. So the building was seeing, it was challenging itself. You lost, if that's your envelope, your windows, and now you've got doors and windows open, you might as well have had a big hole in the building saying, outside air, come on in. So when we see operable windows, that's a huge opportunity, not to say, what are you going to do about security? What are you doing about birds? What are you doing about other things that might be getting into your building? I think I've said enough about operable windows. HVAC grills, when you're walking the building down, again, intakes, exhausts, are they near each other? Do we have exhaust points near loading docks? We see that a lot. And because of VFD-driven supply and return fans, how many of you know this, that your exhaust point can actually become an intake point if you're not operating your return fan properly? It can. If I slow my return fan down to the point that my supply fan overpowers my return fan, it will start sucking in through the outdoor intake and the exhaust, what should be the exhaust point. And if that exhaust point is near a loading dock, and we found that, believe it or not, at another college. So again, indoor air quality issues potentially. Doors, again, how many doors do we have? Are they sealed up properly? Can you see light underneath the doors? In the middle, if it's double doors. Check whether the building is positive or negative at your outside doors. How do we check whether the doors are positive or negative? Yeah, Marta knows. We pull out our $1 test tool. If you got a $20 test tool, toilet paper, something, tissue paper, whatever, and check. We actually checked last night one of the buildings. It was nice and positive, so that was good to see. So that meant that Towson is doing something good. It's problematic in large buildings because of stack effect, and sometimes you can't do anything about it. But for I'm saying most of your buildings here, stack effect probably not going to be an issue. Windy days, it's not a good time to check because you're never going to get a good reading. So calm days, check your building, see if you've got any infiltration going on or excessive exfiltration. We don't want doors slamming open or closed. We don't want to hurt students. Outside lights, are they on during daylight hours? Again, that's an opportunity. Parking lot lights, possibly another opportunity. A lot of vendors now have solutions for parking lots. It's not cheap, but it's something to be aware of. Outlets, are they sealed? Honestly, I don't spend a lot of time looking at outlets, but expansion joints on buildings. Again, college campuses, a lot of buildings have expansion joints. Yeah, we found one building where all the caulking or whatever the material was in the expansion joint was gone. The building was negative, so sucking it right in. Walk the inside of the building. What are your lighting technologies in the building? LEDs, T8s, T5s, hopefully not T12s, hopefully not magnetic ballasts, hopefully not incandescent bulbs. But again, that's why you walk the building down. Now, some of this might be a cost, but it's something that you identify as an opportunity. What's the temperature in the hallways? What's the temperature in the spaces as you're walking the inside of the building down? Do we have wind tunnels going on in hallways? I love this picture. And if we see this in the summertime, and it's more dominant in the summertime, what does that indicate? Too cold. Portable heaters, again, we saw in the previous slide. Thermostat locations, who's got it? Is it in one office and the VAV box is serving 5 or 6 offices and they're gone, they're on vacation, the lights are off, so it's cooled down to the point where everyone else is hot because the thermostat's in a cold room, or vice versa. Those are challenges. Don't really have good solutions. Well, we do have solutions, but they come with a cost. What we've done is we've put in a lot of wireless temperature sensors and averaged every other office. Wireless sensors could come down in price, but it still costs money. We did it not for energy, we did it for complaints. So if people are complaining all the time, that might be a solution to think about. Again, what we want to help people avoid is pulling out their portable space heater. They're an electrical load that can be a fire hazard. Some people have restrictions against them. They're just another plug load. Corner offices, we've talked about corner offices, challenges those present, especially if they have the thermostat. Occupancy sensors for lighting. How many of you guys on your campuses and your buildings have occupancy sensors, motion-based, infrared? So do we check them? Are they working? Are the lights always on? We may not know because, and it's not on a BAS probably, but that might be where, when do I do a walk down? We haven't really talked about that. We're going to do a walk down during the day. Is there any value to doing a walk down at night? You bet. Is there any value to doing a walk down on a weekend? You bet. Well, are you going to pay me overtime to do that? No way. So, well, I guess it's not going to happen. Again, there's things that go on in our buildings at night, on weekends, we're not aware of, so we assume. And sometimes coming out on a night or on a weekend is a huge opportunity because things are found that we would otherwise never see. Last one there, we always ask everyone if they're comfortable, right? That's an open-ended question. But there's always going to be the people that want to complain. We know that. That's the nature of human nature. But there's other people who are probably going to be 90% honest with you. You know what? It was fine this morning, but this afternoon I noticed that it got really cold. And we can tell them, yeah, we know why. They turned the chiller on. Or whatever it might be, So, but until we ask, we're missing the piece. And these are the people that we're serving in these buildings. So otherwise, their only recourse is to go call and complain. And we may not get to the root cause of what it is until we go out and talk to them.
Usually in my experience, we've found that some people don't want to complain because they're fearful it'll go the other way too far.
Yeah.
In other words, so in the cooling season, I think they can put on a little sweater, but they're fearful of if they report they're too cold, it'll swing back the other way. But I think Don and Keith and everything are working things out a lot better.
Yeah.
Ron, you had a slide on louvers there. I just wanted to share something, a little bit of my education. That the code is very prescriptive about screening on louvers. and 1/4 inch to 1/2 inch, but I've seen a number of different cases where insect screen on outside louvers.
Oh, yeah.
And I've seen it on large projects like NIH and a couple other places. But anyway, that's another checkpoint, is look at your outside louvers. We still have some buildings here where the outside air louvers are right at ground level.
Yeah.
And pretty large. And I think it's a trend away from that now for security reasons. But anyway.
Yeah, grass clippings, we see this if you've got a lot of grass and your landscaping, your people that are doing maintenance, cutting grass, you know, they might cut and blow. And if you got air-cooled chillers and they've got condensers and they're on a pad sitting out around, surrounded by grass, we see this a lot. You get up and you look underneath at the condenser coil. Again, it's out of sight, out of mind until you physically go look, plugged with grass debris. So what's that mean to your efficiency on your air-cooled chiller? It's being challenged. It's a huge opportunity. So there's all kinds of opportunities if we start walking down and looking at places we typically never look. Don't assume anything. Just go in with your eyes wide open and start lifting rocks, so to speak, and looking for opportunities. A side story about occupants complaining. The Department of Defense, Army bases, Air Force bases, some are real aggressive, and their culture, they can be really dictatorial. You got the general, the commandant, and so let it be written, so let it be done. And they can really, some not so much, but in any case, this one site, I won't say where it was, someone called up and they said, I want to complain. It's 74 degrees and it should be, I'm not comfortable. And the person said, oh ma'am, thank you very much. I'm going to pull it up on the BAS right now. And yes, you're right. I see that it's 74 degrees in there. Army regulations say you should be at 76. Thank you very much. I'll raise you 2 degrees. No, that's not what I was calling about. Well, no, thank you very much, ma'am. I'm glad you brought that to our attention. So, it can be a double-edged sword complaining. Most of our buildings probably are not that kind of a culture or environment where if someone, we would probably move the needle the other way just to solve that occupant complaint. Okay, so while we're walking down, we've talked about this already. Do we see wall heaters, ceiling heaters? Are they electrically heated? Are they hot water? Are they interfaced? Are they synchronized with the primary VAV box? We see a lot of buildings that have separate baseboard heating systems. They run on their own. They're not in any way interfaced or integrated with the VAV box controls. Problematic because they're over there sitting there heating away, and the VAV box with its thermostat saying it's too hot in here and it's trying to remove the heat. So again, that's potential simultaneous heating at the baseboard, cooling from the air handler situation. How to solve it? That might require some investment. It might, like we said earlier, mean that we just go and valve it out seasonally. Don't know. Whatever you can afford. Or we just ignore it and we keep heating and cooling in the same space. Discharge ducts. Do we see that someone's taken cardboard? Are they adjusted right? In the small building retuning, we talk about looking for signs of dust on the ceiling. What's that indicate? Do we have filtration issues? If we got up above the ceiling, do we find ductwork that's come loose? We typically, on this level of training, don't emphasize that. Again, measuring temperatures coming out of diffusers, looking at wall temperatures, space temperatures, so on and so forth. Portable heaters we've already talked about. Thermostat locations we've already talked about. How is the space being used? Is it an office space? Was it converted to a training space? Was it converted to a data center space? Was it being used for what the engineer originally designed or intended it for it to be? And I won't answer that question.
Sexualizing too, they'll take a large room and split it into like 3 or 4 small rooms, and then the airflow is really inconsistent.
Yeah, and that happens, so we chop, slice, and dice, and it adds to the problems. Occupancy sensors, we've talked about that. Are they working? Are they hidden? Unusual noises. Do we hear, either because we've got high static pressure and the dampers are squeezed down, now we hear a whistling noise coming out of the diffuser. That could be indicative of excess static pressure. If we've got rooftop units, we might hear belts, noise, or even air handling units that transmits down the ductwork. Again, talking to the occupants, finding out when they're comfortable, when they're not. You know, can we connect the dots to what's going on, either with equipment, with the controls, or both. And then the facility manager, hopefully, if you're not the facility manager, but you're doing this as an exercise, hopefully they got their pulse on what's going on as far as complaints. Walk down the roof. We'll be doing that tomorrow. So we want to look at HVAC equipment. If it's rooftop units, a lot of rooftop units, and air handling units for that matter, they all have doors, panels. Maintenance comes, they got to do some repair. They pull the 6 or 8 screws off, zip, 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 pull the panel off. They're done. Everybody pats themselves on the back. We greased everything. We changed filters, changed belts. We put the panels back on. Oh, it's time to go to lunch. We go zip, zip. We only put 4 screws in and off we go. So that happens. So do we see screws laying on the roof deck? Maybe those become puncture points for the roof. Now I got leaks. More importantly, the panel maybe not quite screwed on as tight. So I'm moving air through that unit, and now I got some leakage that I created. Condenser fans, if it's air-cooled, chiller or rooftop unit, it failed. Guy went up there, yeah, it failed, pulled it off, didn't replace it. So now I got a cooling system that's only got half of its capacity because I executed the remove part, but I didn't execute the replace part. How's my maintenance going on? Coils and filters can be problematic. Cooling towers, water leaks, insulation that's been, because I'm walking across piping or just the nature of the beast, I got to remove insulation to replace the valve or fix the leak. Did I put the insulation back on? A lot of times the answer is no. Exhaust fans up on roofs. How many exhaust fans do I have? What are they doing? What do they serve? Are they general purpose? Are they on the BAS? Do they run 24/7? If I go down to the electrical room and it's got a motor control center with handoff auto switches, how much of my equipment that's on the BAS, and we see this a lot on exhaust fans, are not in auto but are click, click over in hand. Because if they're in hand, they're not going to shut off on my schedule. They're just going to keep running, and I may or may not know about it. Same with pumps and other equipment. So again, we talked about legacy fan and duct systems, so I'm not going to belabor that anymore. Are they removed? Are they capped? Then we're going to look at air handlers. How many do I have? I know the building we're going to look at tomorrow's got almost 20, I believe, air handlers, so we're not going to look at all 20, believe me. If I'm walking them down, I want to get a sample, maybe up to 50%, so that might mean looking at 10 of them. I don't know that we'll look at all 10 tomorrow. But I want to get a random sampling. If I find a problem, and I want to go to the next one and see if it's consistent. Is it because of the vendor? Is it how I'm doing maintenance or not doing maintenance? Is it a single zone, constant volume? Is it multiple zone? Is it VAV? Does it have VFDs? Does the VFD tell me how fast it's running, how much load, amperage-wise? If I open the door, either on the return or discharge side, do I see the static pressure change and therefore the fan respond to that? If not, it probably means it's overridden. If I've got inlet vanes, anybody have fans with inlet vanes still? Oh. Groan. You have my sympathy. Not for long. So if I have inlet vanes and I put a VFD on the fan, do I leave the inlet vanes in and lock them wide open, or do I remove the inlet vanes? You do either or. Somebody said get rid of them. Now if you lock them in place, wide open hopefully, you're still paying a slight penalty for pressure drop across those inlet vanes, number one. Number two, you don't know mechanically if they're coming loose inside and creating more of a restriction. So,
yeah, our only restraint on that was the cost associated with tearing them out on that job. It would take forever to pay it back opposed to just locking them in place.
okay.
We have some that are in pretty bad areas
Yeah.
where you'd have to cut walls out to actually get that fan
Okay.
out.
Yeah.
So we're actually getting ready to start this job next month, beginning of next month.
Okay. So my only comment to that would be just periodically check the,
You have to check them out and keep an eye on them.
yeah.
Mine's still working, I'm gonna get rid of it.
Depending on the type of fan system, some people, what I've read, have said that you might create some added turbulence because those vanes do some air straightening out on the fan if it's a dual inlet. But anyway, just things to be aware of. If you can get rid of them, by all means, I would say get rid of them. Add a VFD, and you will save energy with inlet vanes, but not nearly as much with a VFD. There's, I could show you, there's a study done by a couple guys, but yeah. Again, whether it's an air handling unit, rooftop unit, look at your coils, your filters, dampers, damper linkages, end seals on dampers if you've got them, belts, motors, doors, valves, all those things. Basically what we're looking for is condition of maintenance. Do we see coils or filters that are plugged, collapsed filters, belts that are fraying, belt debris laying on the floor or whatever, dampers that are damaged. Again, we've talked about dampers. Water leaks. If I've got a condensate drain pan on a cooling coil, is it working properly? Is the water actually coming out through the P-trap going to the drain? Or is it plugged? Or even worse, is it sucking air back in? And where do we normally pipe P-traps to? Floor drains. And what's the floor drain connected to? Sewer. And what's coming up potentially if my floor drain's dry? Sewer gas. Something to think about. So again, prime your traps, prime your floor traps, prime your P-traps. You probably don't have to worry about that. We do because we're in a dry climate, but I have seen it even out here. Water valves, heating valves, cooling valves, leaking, whether they're cut, packing, excess pressure. Motor frames, enclosures, air-cooled motors, are they too hot to touch? You should be able to put your hand on a motor, hopefully, at least for a few seconds. Infrared camera, if it's above 150, 160, you probably are, unless it's rated for that, you might be looking at a problem down the road. Okay, the controls, BAS, DDC, whatever you want to call it. If I've got panels, do I see the wires have been disconnected? Maybe they got handoff auto switches inside their panels. Some of them do. Are they in hand or are they in auto as well? Do I have jumpers in place? Ductwork, do I have gaps, leaks, flexible couplings that have come apart, vibrations? Quick story, another school went to do this type of training. I had to go up into the attic space. Principal was there, teachers were complaining. It was a 70-degree day, very hot, stuffy. This is Washington State, dry, not hot, humid, but hot. So metal roof. We were expecting to be exceedingly hot in the attic space. We went up the ladder, got up above the classroom. It was nice and comfortable. It was like 60 degrees. And the ductwork had come mostly apart, so that conditioned air was blowing mostly into the attic space and not getting down the ductwork and out the diffusers. Classrooms were hot and stuffy. So we came down. Oh, and by the way, the metal deck had 6-inch batch insulation bats, 6-inch thick. Half of them had come loose, fallen down off the metal deck. So, which, we still expected to be, when we saw that, we go, man, it's got to be hot in here. But, we took readings, nice and comfortable, found the ductwork that had come loose. We could feel air movement. So we came down, we told the principal we had good news, bad news. Good news, it was very comfortable up there for his maintenance staff. The other good news was you had an automatic snow melt system for your roof. And he goes, I was wondering why all that snow it would never stay up there on the roof. So, you got to look on the bright side of things, but on the downside, the teacher, the students were suffering again in a classroom where the ductwork had come apart. Nobody ever went up there to look. Got to go look. So we talked about noises, location of outdoor air sensor. We always, not always, I would say 95% of the time run into this. And again, we're using outdoor air sensors for calculating enthalpy. We're using outdoor air sensors for determining resets on discharge temperatures. We're doing it for a lot of things. Real important to validate where that sensor is located. Another story, I got a lot of them. But we went up on a roof. Here's a cooling tower. They put the outdoor sensor underneath the cooling tower. It's shady, you know. But it was reading, they had outdoor temperature and humidity sensor right underneath the cooling tower. Temperature, probably not an issue. The humidity sensor was reading actually unreliable. They had the steam relief valve from their boiler system come up through the roof, and it was piped, and it was like this far away from the humidity sensor. And it was constantly relieving. So that humidity sensor was always getting a nice shot of steam, which was giving a false reading, and eventually it just burned it up anyway. So location, location, location. Walk your plant. Look at your pumps. Are they running? Are they vibrating? Are they excessively hot? Are they in parallel? Are they parallel piped pumps with VFDs? Fans and VFD and pumps that are in parallel. Huge opportunity for the affinity laws for cube savings. If you run them in parallel, a lot of people don't like to, because if I got two pumps, two fans, you want me to run them both? What if one fails? Well, the other one will just pick up speed. But yeah, you just lost your backup. But there can be significant energy savings running parallel. And we see more and more people doing this on 100% outside air. We talked about labs. So somebody said, I got vivarium and I've got biological labs, 100% outside air. What we're moving to on our labs is we got 4 fans or 3 fans that move supply air or exhaust. We're running all of them. They're VFD driven, and the sum total of each individual fan with VFD is less than if I ran 1 or 2. Great opportunity. Insulation on piping, look for that. Don't assume that you don't. Again, that's where the infrared camera can come into play. We see a lot of mechanic rooms, people go through and they paint everything black or everything white. All the piping looks pretty, but now if I've got uninsulated steam or hot water or condensate lines, I'm not really thinking that way because I'm just seeing everything painted the same color. Or if I go into a building and it's no drop ceiling, it's right up to the roof deck above me or the floor above me. We see a lot of buildings with black, because it just, hey, we'll hide it. Well, until I start looking up there, I may miss piping that was not insulated or it was removed. Same with the floor. Look for your floor. Don't assume you've got steam lines right underneath tunnels or whatever. Constantly are finding hot floors. I wouldn't know it because I'm walking with insulated shoes, and if it's 80 degrees, is that normal? Probably not. What's underneath? Oh, let's go look. Pressure differences of more than 40 psi abnormally high for closed loop systems. We talked about 10 to 20, so yeah. Boy, I hope nobody has differential pressure differences between what's being supplied and returned that high, especially at the end of your loops. Again, look at your chillers, your boilers, your towers. How many are running? Are they running part loaded? Are they running for the load? Are they running unloaded? Are they short cycling like we talked about earlier today? If your BAS has the ability to calculate when it's on or off and count number of cycles, and a lot of equipment now will tell you, a lot of the vendors are embedding that data in the chiller and in the boiler. The next question is, okay, how many hours did it run? And that's also, you can either create that with your BAS, runtime hours, or it's embedded by the vendor. So if I'm running, we'll just say I pick a nice round number, 10,000 hours, and I had 20,000 on-off cycles in that 10,000 hours. What does that mean? It means on average, every 30 minutes I'm cycling on and off, running that equipment to failure. Now, I'd be more worried about equipment longevity than energy, but I'm guessing that if I fix the energy piece, I'll fix the cycling piece. So again, it's a huge opportunity with BAS systems to look at that. The vendors are putting that data into their equipment. You can pull it out if you're integrated, or you can do it on your own with your BAS system. Automatic and manual isolation valves. Talked about this earlier, but we do find this a lot where people are using the manual isolation valves for a balancing valve. And on VFD-driven systems, it's not a good idea, but we consistently see that. It's an opportunity. automatic valves should be automatically working and should be closed if the boiler or the chiller that's serving is off, and I should not be flowing water through that boiler chiller. How do I know if it's flowing water? Look at the temperature gauges right there in the plant, or look at your BAS, your trended data. We've talked about this, our system's in hand mode, when they should be in automatic, or they manually overridden on the BAS. The last thing is the DDC system. Do we scan for things that are online, offline? Do we know what's in alarm? Do we have code that's disabled? Do we have graphics that are accurate? Do I have a built-in electric or gas meter, or water for that matter? Is it connected to the BAS? Oh, I'm sorry, yeah.
You talked about water flow and not needing, recommended for somehow to sense your makeup. There's a lot of, I can assure you, there's a lot of towers that are overflowing and nobody ever knows it.
Yeah, that's why we do a walk down. The building I
meter your
talked about
makeup.
last year in June in New Jersey, is doing exactly that.
And it doesn't cost that much and it will pay back. Water is, if you're paying for water, not only that, but if it's going somewhere, we are close to tributaries.
Yeah.
And when chemicals show up in tributaries, someone has to answer for how it got there. So, I mean, metering your water, your makeup water.
I agree.
If
And
if you're gonna meter the water, you can subtract that from your water bill.
Well, that is done. That is done from your sewer bill, but you know, it's not hard to do, calculate your evaporization rate and compare that to water makeup. And then just flag it into BAS. It's not hard to do.
great comment, good point. Anybody else run into that issue with cooling tower, makeup water? They just, yeah, blow down, yeah. So again, these systems, automatic systems are nice. Their technology is great, but I think what you're hearing from all this discussion is the human element still has to be inserted. We still have to manage it. We still have to validate it. We still have to walk it down and ensure that it's running properly, because if we don't, it can get out of hand real quick. So again, the last bullet there, trending of key data points should be working. Are we using the trending capability? Do you know how to set it up? Is it working? And are you periodically reviewing selected trended data points to see how things are performing? Or are you alarming them like you said? So it's very important to use your BAS